Microchip's 8-bit PIC microcontrollers provide a function called timer zero that enables precise timing, which is essential for tasks like controlling communication, producing frequencies, and keeping time. Interrupt on change is a feature in microcontrollers that triggers an interrupt when an input pin changes state. This will allow the microcontroller to quickly react to changes in its environment. Setting up IOC depends on the specific microcontroller, and resources like Microchip's documentation and online tutorials can help. Using the hashtag include directive, the code includes the header file mcc underscore generated underscore files slash mcc.h. Important definitions, parameters of the microcontroller configuration will be provided in this file. The program starting point, which is the main function, is defined. Uh, the interrupt underscore global interrupt enable and interrupt underscore peripheral interrupt enable are used to activate interruptions. By triggering global and peripheral interrupts respectively in response to external signals or timer overflows, these features enable the microcontroller to react. These are the codes that we have used for the one LED setup and multiple LED setup. For the one LED setup, the IOC BF4 underscore default interrupt handler function is shown. When the IOC BF4 interrupt, which is caused by a change on a particular pin, occurs, the function will act as the default um, code. By default, the code uses the D2 underscore LED underscore toggle function to toggle the D2 underscore LED, turning it on or off. For the multiple LED setup, the interrupt on change configuration of the switch was configured to activate on a negative edge. Four LEDs were connected to pin 3, 4, 6 respectively, and they are connected in a configuration like in part in the one LED circuit. Every time the switch is pressed and released, the state will transition from high to low, which will trigger the interrupt on change, which will be detected by the IOC BF4 interrupt, which will toggle the state of the LED connected to the microcontroller. So the multiple LED setup is just an expansion of the one LED setup. They use the same function, the IOC BF4 underscore default interrupt handler. For a one LED circuit, a 220 ohm resistor was used to connect a red LED to pin 6, which is the anode to pin and cathode to ground. One terminal of the switch was connected to ground and the other terminal was connected to pin 37 and the positive 5 volts via a 10 kilo ohm resistor. For a one LED circuit, a 220 ohm resistor was used to connect a red LED to pin 6, which is the anode to pin and cathode to ground. For our first attempt at the multiple LED circuit, we had some malfunctions in the circuit connection. We also tried on troubleshooting the code itself and tried looking for alternatives on how to make the multiple LED circuit work. Instead, what we did is to redo the circuit, redo the code, recompiled, and redo everything that we've done in our attempt for the multiple LED circuit. In our successful attempt, Myrnie had troubleshooted the circuit correctly. Four LEDs were connected to pin 3, 4, 5, and 6 respectively, and each had a 220 ohm resistor that is connected in a configuration just like the first part. The program was created to use interrupt on change to toggle the LED whenever the state of the switch was changed. The switch caused an IOC interrupt, but this time every LED toggled, which was an enhancement of the first part of this lab experiment. We can conclude that this experiment effectively illustrated how to utilize a PIC16F18875 microcontroller and interrupt on change to control LEDs. We used the MP Lab IDE to program the microcontroller to turn on and off LEDs in response to the switching of inputs. The ability of the microcontroller to control several LEDs was also demonstrated by the experiment. We carefully check the settings, pin configurations, code, wiring, and component status, which is essential in making sure that this experiment was successful. The 8-bit interrupt on change system was vital in this lab experiment as it tracks the changes in status of the levels of each of the circuit, which in turn changes the status that will be outputted by the controller. That's it for this experiment. Thank you very much for listening. We can conclude